Okay, so we're going live. And so the way this works is you have already posted the questions, and I'll explain them to you and write on them, and then you stop me if you're confused by something.
Okay.
All right, so this first one says here, simplify the expression using exponent properties, and they don't want you to have negative exponents in your answer. So do you know the properties of exponents? Are you familiar with all the properties of exponents?
Like when you're multiplying exponents, it's just like adding them, right?
Right. Do you have like notes for it?
Yeah, I do. Do you want me to like get them out?
You know what? If you did, that'd be good, because that way I can refer to it the same way that your teacher has taught you. There's lots of different ways to, types of variables to use when you're expressing the properties. But if you can, if you can post it on here, I can just keep referring back to it and show you what it is that I'm doing.
Okay.
Do you want to just read them off to me? Would that be easier?
Yeah. Let me just
Okay.
find it real quickly.
Oh, you're still looking for it. Okay.
Oh, I have it.
Perfect. So I'm going to put it on this first page. Go ahead. Tell me what you got.
I just have like the exponent rules or whatever.
Yep.
Actually, no, I can download it really quickly. Hold up.
Okay. Yeah, if you just take a picture,
Yeah.
you could just take a picture of it and then post it on page 1, and I'll just keep going back to it to refer to it. Another way we could do it is I could just go online here and find like properties of exponents. I just want it to be consistent with what your teacher says. Does it look like something like that?
Hold on. I'm taking a picture right now.
Oh, perfect.
I'm not sure if you can see it, but let me know. It's really hard to see, but nah, it's so blurry. Hold up.
Yeah. Does this one look pretty similar to what you have?
No, not really.
That's not the letters you use?
But like, yeah, but like with like the rules, like not the proofs, like we're not working with that, but like the rule, like the first, like 1 through 8, like those are the ones that we use.
Yeah. Okay. The proof on this example is just kind of gives you some, it's not really a proof so much as an example, right? So let me see if I can add that image. There we go. So I'll just keep referring back to this. See if I can drag it to the next page. Oh, there we go. Perfect. All right, so there it is. So I'm going to refer to these.
Okay.
Okay. So you can see I have x to the 4th Well, first of all, I like to deal with the numbers, right? So my numbers are 4 and 7. So what you can do is you can think about rearranging these. 4 times 7 times x to the 4th times x to the 3rd times y squared times y to the 6th times z to the 3rd. And you don't actually have to rearrange them like this, but I'm showing you just how mentally that's what you're thinking about, right?
Yeah.
You're dealing with them in this order. So what's 4 times 7?
28.
Good. And what do you do if you have 4 x's and then another 3 x's in total? How many x's do you have?
7.
7, right? And that's this first property over here. You add the exponents, right? Does that make sense?
Yeah.
And similarly, you add the exponents 2 and 6, which is what?
Y to the 8th. And then this is where I got a little bit confused because I thought it'd be z to the 3rd, just because like the other z didn't have like an exponent with it.
So if there's no exponents here, what is the exponent up here? Is it 0 or is it 1?
1.
Yeah, it's got to be 1. So even though they don't write it, you have to remember there's a 1 there. If it was to the 0, then that would be the number 1, right? Anything to the 0. For example, there's w to the 0. There's no w's there.
Yeah.
And that literally just means that how many w's are here? None. Well, if there's none here, you can't call it 0 because 0 would wipe this whole thing out. 0 times anything is 0. So you have to say that it's 1 because 1 is the identity for multiplication. That makes sense?
Yeah.
So that's why
0 there, then it won't be 1.
Right. They wouldn't even write a 0 there, right? You understand?
Yeah.
The point that I was making is that can't be a 0. There can't be 0 z's there. There has to be 1 z. So that's
Okay.
what that the exponent just means how many of them there are.
Okay.
Okay, make sense?
Yeah.
All right, so let me drag this exponent rule to the next page in case we need it here. Oh, I don't think we're going to need it here. So this question says describe the end behavior. All right, so when we're talking about end behavior, let me tell you about end behavior. The easiest way I can think of it is this. The first thing you do is you look at the leading coefficient.
Yep.
If the
Which is
leading
4,
coefficient is, which is 4, correct. If the leading coefficient is positive, then that means that the right end behavior, REB, right end behavior is up. Okay. If the leading coefficient is negative, then that means that the right end behavior is down. So that's the first thing you look at. The second thing you look at is the degree. If the degree is even, then that means that the left end behavior is same as right end behavior. If the degree is odd, then that means the left end behavior is opposite of the right end behavior. Okay?
Yeah.
That's the easiest way, in my opinion, to do this. Some teachers don't teach it that way, but to me, that's the easiest way. So the first thing is you look at the leading coefficient. What's my leading coefficient?
4.
Which is positive or negative?
Positive.
Mm-hmm. So since the leading coefficient is positive, what does that mean?
It means that's going to be pointing up.
On the right.
Okay.
That means on the right, it's going up. Right?
Yeah.
Now let's look at the degree. What's the degree?
6.
Which is what, even or odd?
Even.
Mm-hmm. And since the degree is even, what does that mean about the left-hand behavior?
That it's that's the same as the right end behavior.
Which is what?
Positive, which is going up.
Which is up, exactly.
Okay.
So your answer should have been, your answer looks like it was right. Did they not call that right?
No, they didn't call. Well, it was just blue. So I think it's like somebody else has to grade it, if that makes sense.
Oh, got it. Yeah, that looks like it's correct.
Okay.
It might be a little wavier or something, but it doesn't really matter. They just want to know the end behavior.
If it were like if the leading coefficient was like 7, which would be odd,
That
then
doesn't matter. Leading coefficient doesn't matter if it's even
sorry,
or
not
odd.
the leading coefficient, my bad. The degree was like 7.
Uh-huh. Then it would be opposite.
How would that look
Correct.
on a graph? Do you know?
So it would just do that. This side would be going down. If this was like 7 here,
Yeah.
then the left side would be going down. So it would be doing something like this.
Okay.
In fact, there's another thing. Have you learned about peaks and valleys?
No.
So the other thing that you know is that the leading coefficient also helps you, the degree. The max number of peaks and valleys.
Sorry, what'd you say?
The maximum number of peaks and valleys is equal to the degree minus 1.
Okay.
And the number of zeros or x-intercepts is less than or equal to the degree. So you know for your problem, since it said the degree was 6, you actually could have had 6 x-intercepts. And you could have had 5 peaks and valleys.
Okay.
You understand?
Yeah.
So it could have gone like this. 1, 2, 3, 4, 5. That could have been your graph. You see how I have 1, 2, 3, 4, 5, 6. I have 6 x-intercepts, and I have 1, 2, 3, 4, 5 peaks and valleys.
Okay.
Good for that one?
Yeah.
Okay, this one says solve
This
the
was grouping,
polynomial
right?
using any method. Yeah. So the method for this one is going to be grouping. So you know how to do that?
Yeah. Wait, so p to the third, I'm just writing it down on my paper.
Okay.
Minus squared plus
So what's
8.
the first step?
You have to group like the two, like you have to put like both, like the 2 in parentheses, if that makes sense.
Mm-hmm. Yep. Those 2 and those 2.
Yeah.
So what do you factor out of the red group?
Your greatest common factor,
Which is what?
p to the third. Or my bad, p squared.
Good. And if I do that, what's left behind?
P minus 2.
Good. And how about the blue group? What am I going to factor out?
-9.
Good. -9. If I factor a -9 out, what's going to be left?
P minus 2.
Perfect. And that has to be p minus 2, right?
Yeah, because they have to be the same.
Yeah. And now since I have the same thing, I can factor that out. If I factor that out, I'm left with p minus 2, which came out, and what stays in?
Sorry, what'd you say?
If I take a p minus 2 out of the red group, what stays behind?
P squared minus 9.
Good. P squared stays behind for that, and a -9 stays behind for that. Perfect.
And
Now,
then,
how can this factor?
don't you have to equal it to 0?
Right. But how can this factor still?
Oh, well, there's no greatest common factor.
How about difference of perfect squares? Can you see a p minus 3 and a p plus 3?
Oh, yeah.
Do you remember how you can do that if you have a difference of perfect squares? That was this property, a squared minus b squared factors into a plus b times a minus b. Do you remember that property?
Not really.
Well, there you go. Look at it. If you do A, what happens if you do A times A? What do you get?
A squared.
And what happens when you do A times negative B? Negative AB.
Yeah.
And what happens when you do B times A?
BA.
Positive AB.
Oh,
And
AB.
B times negative B, negative B squared. What happens to these middle two terms?
They cancel each other out.
Yeah, and that's why you just get A squared minus B squared.
Okay.
That's why that works. You know, it might be easier for you to see it if you wrote it like this. What's P squared minus 0P minus 9? How does that factor? Can you see now that what adds to what two numbers multiply to negative 9 and add up to 0?
Plus 3 and minus 3.
Exactly. Okay.
Okay.
Does that make sense? So what are my zeros? What are my solutions?
So then
Do you know how to solve it from here?
Yes. So P minus 2 equals 0.
Yep. So P equals what?
P equals 2.
And the other one?
P minus 3 equals 0.
Which means P equals 3.
Yeah. And then
And
P
negative 3.
Yeah.
Those are your answers. Good.
Okay.
Okay, this next problem says find the roots or zeros.
Yeah.
So for this one, what's the first thing I should do?
Okay, so because it's in 3, can't you I don't know how to explain it, but I forgot what it's called. It's like solving by fact, or you make the add,
Factoring.
and then you do
Yeah.
A times C, and then you put B at the bottom.
I'm not sure what you're talking about, but let me just tell you how I would do this problem. The first step is to factor. And what can be factored out of all three of those terms?
3.
And
3x.
how about an x? Yeah. So then you'd be left with x squared minus 3x minus 10.
Yeah.
And then can you factor this thing now?
Yes.
How does that factor?
Negative 10, negative 3.
Think about what adds to negative 10. Or sorry, multiplies to negative 10
Yeah,
and
that's what I'm
adds
thinking about.
to negative 3.
Oh,
Well, you know,
my bad. I got it. Negative 5 and 2.
perfect. Okay, so I have factored it completely, and now I set that equal to 0 to find the roots, right?
Yes.
Which means I set each one of these equal to 0. And we can do this part in our head, can't we?
Oh wait, that's not. I once I have my 2, I subs it in for the middle term. So then I'd have
No.
x squared minus 5x or minus 5x plus 2x minus 10.
Well, then you would just get back to where you came from in the first place. That's how you check if you did it right, but you don't want to do that. You don't want to go backward. The reason you factor it now is because now you use the zero product property. You use the fact that since here's the zero product property. If I tell you that A times B equals 0, what has to be true? What's the only way to make a product of two things equal to 0?
Um,
I'll tell you what, I'll give you $10 if you can tell me two numbers, neither of which are 0, that multiply to 0.
I don't know.
You can't do it.
Oh,
What's the only way you could make two numbers multiply to 0?
by multiplying 0.
By one of them has to be 0. Either A has to be 0 or B has to be 0. It's the only way. Right?
Yeah.
And if A is 0, does it matter what B is?
No.
It doesn't matter because it's still 0. Or if B is 0, does it matter what A is?
No.
No. So this is called the zero product property. If you have two numbers that multiply together and get you 0, then that means that one or the other has to be 0. And so that's what I'm doing with this equation. See how I've got this times this times this equals 0?
Where'd you get
The
the
reason
yeah.
because I factored it out. Look at the beginning. See, right here, could I use the zero product property? Look at the beginning. Could I use the zero product property right here? Do I have things multiplying together to make 0?
No.
No, these are being added or subtracted, right?
Yeah.
But now look at what I did. I changed this equation from 3 terms to 3 factors. Actually 4 factors because I've got a 3 here. But this 3 doesn't really matter because that's not a variable. Do you understand? So the zero product property says that either 3x equals 0 or x minus 5 equals 0 or x plus 2 equals 0. Well, now what kind of equations do I have? What kind of equation is that?
Division, addition, and subtraction.
Yeah, this is just, yeah, exactly. And these are just linear equations now, right? I can solve this. How do I solve this equation?
You subtract.
So x equals -2. How about for this one? X equals 5, right? And how about for this one, the first one?
X equals 0.
There are my 3 answers. Remember I said that number of the degree tells you what the maximum number of answers you're going to have? The maximum number of zeros? That's how you know you did it right, or one of the ways.
Oh, if you have 3 like solutions.
Yeah. You don't have to have 3, but you can't have more than 3.
Okay.
Now, I'm going to show you a trick. Okay? Do you have this graphing calculator?
Not on you right now, but I can watch from here.
Yeah, just watch. Can you see what I'm doing? I'm going to show you first I'm going to show you A, how to check your answer, and B, I'm going to help you understand what I was just talking about with the zero product property, right? So I'm going to say 5, typed in 5, and do you see that store button in the lower left corner above the question mark?
Yeah.
It says STO. I'm storing that for X. Okay. So every time I type in X, it's going to substitute a 5 in there. So what's 10 plus X going to be?
15.
Good. Got it?
Yeah.
So I'm going to type in what the original problem said. What was the original problem again? Read it to me.
3x cubed.
3x cubed.
Minus 9x squared.
Minus 9x squared.
Minus 30x.
Hold on. 3x cubed. This is a little different than mine. 3x cubed minus 9x squared.
Yep.
Minus 30x. And when I hit enter, what should I get for my answer? What was the whole point of what we were just doing right here?
To find the roots / zeros.
Yeah, we were trying to find out what numbers solve this equation. We were trying to find out which numbers, when I plug it in for X, give me 0. Because that's what it means to be a root. A root means it's where Y equals 0. That's what a root is. So your graph looked something like this. And we're trying to find these 3 points right here.
Okay.
And what we did is we solved for these 3 numbers, 0, 5, and -2. Which means when I plug in 0 or 5 or -2 in for x here, what should I get as my answer? What do I want it to be? What do I want the y to be?
0.
Yeah, I want it to be 0. Do you see how I've set it equal to 0?
Yeah.
So watch, when I hit enter, what should I get?
0.
There you go. Now, if I tried plugging in -5, would I get 0? Let's plug -5 in for x. And I'm going to hit second enter. It toggles me back to that equation. Now I'm plugging in -5. Am I going to get 0 now?
No.
I better not. How about when I plug in -2?
Yes.
I should get 0, shouldn't I?
Yeah.
Let's find out. Second enter, toggles me back. Hit enter. There you go. Do I even have to check the 0 one?
No.
Can you tell that you're going to get, if you plugged in 0 here and here and here, you're going to get 0. Can you tell why?
Because it just cancels everything out.
Exactly. Okay.
Yeah. So for if I have like ones like that, like where there's 3,
Yeah.
where it's like a trinomial thing.
Yeah.
Can I always do that equation?
Well, it doesn't always factor.
Oh, how do you know if that?
You just have to try to factor it. And if it
Oh.
factors, it factors. If it doesn't, it doesn't. If it doesn't factor, then you might have to use a different method. Have you learned about the quadratic formula yet?
Yeah.
That's when you use that.
Okay.
Or completing the square. Have you learned how to complete the square yet?
Isn't
That's
that
when
what
you might.
Wait,
We haven't done it. Completing the square is a different method, but we haven't done it yet. Or you could just plug it into your graphing calculator if they let you do that. You literally could plug in 3x cubed. Watch, I'll show you another way you could solve it if they let you use technology. 3x cubed minus 9x squared minus 30x. You could just graph it and zoom in and look for the zeros. There they are. There's -2. There's
Yeah.
0. And there's 5. That's the other way you could do it.
Okay.
Which they don't want you to do it that way, right? They want you to do it. Well, maybe sometimes they don't care. But do you see how I didn't even look at that and I knew? How did I know it was going to be this shape? Can you tell me how I knew that?
Because well, it's odd. So like
Good.
if it's odd,
Well,
it's going
first of all, the leading coefficient is what?
3
Positive or negative?
positive.
So that means what?
That the right
Remember,
side's going in a positive direction.
that's right. That means it's going up to the right. That's why I made it go up to the right. And then it's an odd one, which means the opposite side goes, or the left side goes in the opposite direction.
Okay.
So I knew that was going to happen. And
Yeah.
then I kind of guesstimated that it was going to have 2 peaks and valleys, right? 1 peak and 1 valley. And I knew, well, look, I have 3 zeros. 1, 2, 3. Okay.
Yeah.
So this next one, solve. Now this is a quartic. So how many solutions can you have?
4.
What's the max number of solutions?
4.
4 solutions or less, right? 4 solutions or less. So how am I going to solve this? Well, I don't know any formulas. I don't know how to do this unless I recognize that, wait, this kind of looks like a quadratic, doesn't it? Doesn't it look like, see how there's 3 terms?
Yeah.
So if I rename x squared, if I rename that u, so I'm letting u equal x squared, then this equation really looks like this. 0 equals u squared, because u squared squared would be u to the fourth. Or I'm sorry, x to the fourth. X squared squared, sorry, would equal x to the fourth. You follow?
I'm just gonna like, why are we like putting in different numbers?
So I'm explaining to you why we're going to do it this way.
Wait, are we
It's
using?
called.
Are we
This
using
is called.
quadratic or no?
We are using the quadratic, but notice what we have to do first. This isn't x squared. This is x to the fourth. And this isn't x to the first. This is x squared. So what I'm doing is I'm kind of rewriting this. I'm saying I'm letting u equal x squared. I'm writing it with a different variable. Has your teacher done this? So she probably hasn't done it, but essentially this is what she's doing. She just doesn't, maybe she doesn't explain it this way. But you'll see. Let me just do it, and then you can ask me questions. Okay?
Yeah.
Okay. I know this is a little bit tricky, but it's a good thing for you for the future. Anyway, you're going to have to learn how to think this way. So what I'm doing is I'm substituting this. See this letter here? I recognize that this kind of looks like a quadratic. It kind of looks like this, doesn't it? Doesn't it kind of look like that?
Yeah, a little bit.
It looks a lot like that, except instead of having something squared, it has something to the fourth, right? As the beginning.
Yeah.
So I'm rewriting it so that I can say, oh, I know, I'm going to treat this like a quadratic, and I'm going to just factor it. How can that factor?
Multiply 7 and
What multiplies to 7 and adds to -8?
yeah.
Which is what? Answer that riddle for me. What multiplies to 7 and adds to -8?
It would be. Sorry.
Remember, they can be both
negative.
negative.
-1.
-7 and -1. Good. Got it?
Yeah.
And now I'm going to use the zero product property, which says what?
That anything that you multiplied, isn't that like if you multiply anything to 0, then it's 0?
Right. So what can I do with these two things?
Equal into 0.
That's right. So u minus 7 equals 0, or u minus 1 equals 0, which means u equals 7 or u equals 1. So am I done? I'm not done, because I'm not trying to solve for u. I'm trying to solve for
Yeah.
x. And what was x again? Or what was u again? I'm sorry. Look back at what we wrote. What was u?
X squared.
Good. So now substitute x squared back in. And now how can I solve that equation? If I tell you that x squared equals 7, what's the answer?
X equals plus or minus square root 7.
Perfect. And if I tell you x squared equals 1, what does x equal?
X equals plus or minus square root 1, or just plus or minus.
Well, the square root of 1 is just 1, right?
Yeah.
Good. So there's your 4 answers. Remember I said 4 solutions possible? There's your 4 solutions. And the correct answer is this first one up here. This was that's a tricky one. This is technically correct, but it's not. Oh, no, it's not, because they don't have a square root over the 7. Square root of 1 is just 1, so you shouldn't write square root of 1.
I'm just like, is there any other way to like solve? Because I just get so confused with like the u equals x squared. Like it just doesn't make much sense.
How about this? How about if I said smiley face equals x squared? I'm sure it doesn't do any better, but that's essentially what you're doing. You don't have to do the u thing if you recognize it. Like I wouldn't do the u thing personally. What I would literally do when I saw this, x to the fourth minus 8x squared plus 7, is I would just immediately think, oh, this is just a quadratic. So this is going to be x squared and x squared, right?
Yeah.
And this is going to be -7 and -1. You can do it. You can go straight to that if you want to.
Yeah.
But a lot of times it helps you to think about it more to think about it like this. So that, see how this looks like a quadratic because it's got a squared in it?
Yeah.
This doesn't have a squared in it. I mean, it does have one there, but this doesn't start with x squared. So for some people, it's harder for them to jump straight to here. But if it's easier for you to do that, then sure, go for it.
Could I maybe just try like when I'm, do you like have any like ones that I can just like try?
We can make one up.
Okay.
Yeah. So let me give you another one of that same style. So if I said if I said 0 equals let's see, 2x to the fourth plus 6x squared plus 8.
Okay. So then
Let me see, maybe -8. I have to kind of do it in my head and try to see if it's going to work. Try that one.
okay. So -16 and 6.
So tell me what you're doing first.
Well, I'm seeing what adds to negative. What adds to -16? I mean, what adds to 6 and what multiplies to -16?
Okay, so are you, as your teacher taught you how to do the master product thing? Where'd you get -16?
I did 2 times -8.
So that's called the master product. Did your teacher teach you to do something like that?
Yeah.
Okay, and that doesn't confuse you? Okay, so what does she tell you to do exactly? Because, well, the first thing you should do for this is factor out a 2.
Oh, wait, I can factor out a 2.
Yeah, that's the first thing you should do. So actually, you could literally just divide everything by 2, including the 0, which means you'll get 0 equals x to the fourth plus 3x squared minus 4.
Yeah.
Now what?
So then I have -4 and 3. So then -3, -1.
No.
My bad.
Negative.
It would be what multiplies to -4.
Yeah.
It'd be -1 and 4.
Perfect. And what's in front of them?
Okay, this is where I get confused.
What goes here and here?
Oh, x squared and x squared.
There you go. That's it. Now what do I do?
You equal them to 0. Like you equal each equation to 0.
Okay, so x squared minus 1 each factor. X squared minus 1 equals 0 and x
Yeah.
squared plus 4 equals 0. Now what?
So then you subtract 4 on each side. X squared equals -4. Square root that.
Okay. What do I get?
X equals plus or minus 2.
Well, hold on. How do I take the square root of a -4?
Oh, wait. Don't you have to, like, do the invisible thing?
Oh, yeah. Have you learned that?
Yeah.
Okay. So this is called an imaginary solution. So
Yeah.
x equals plus or minus 2i.
2i.
Okay.
Yeah.
And how about this one over here on the left? X squared equals 1, which means x equals?
X equals plus or minus 1.
Good. So there are my 4 answers for that one.
Yeah.
Now, what if it didn't factor? What would you do if it didn't factor?
The quadratic formula.
That's right.
So then I just go through I can try it. Do you want me to try it?
Yeah. So let me give you a different one to try.
Okay.
And I'm going to make the point that I was trying to make before. If it was x to the 4th plus 3x squared minus 3. I'll just tell you right away that doesn't factor. So how are you going to use the quadratic formula for that?
Label like A, B, and C.
Okay, what's A?
Isn't A just 1?
Yep.
We don't have the quadratic formula memorized because he said that we can like use our formula sheets for it.
Sure,
too.
that's fine. I have it memorized. It's -b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah.
But hold on. This isn't really a quadratic. This is a quartic. You sure you can use this formula? Because that's not going to be x, right? It's not going to be x equals this. Do you know what it's going to be? It's going to be x squared equals this. That's the point that I'm trying to make here. Whereas if you used substitution, if you said let u equal x squared, then you can rewrite this equation as u squared plus 3u minus 3. And now you can find u equals that because that's a quadratic. See how that's a quadratic now? This is not a quadratic technically. This is a quartic. This is a quadratic.
But what if
so
like
you can,
how do you sorry, I know I'm not trying to be against like I just like can I use like the quartic? Like how do I solve a quartic? Because you can't can you group it? You can't group it.
No, that's the only reason that this quartic can be solved is because it can be turned into a quadratic. This is a quartic, but it's in the form of a quadratic. Like for instance, if this was x cubed, you couldn't solve it with this method. If this here was x cubed, this was x to the 4th and this was x cubed, or if this was x to the 4th and this was x to the 1st, you couldn't solve it with this method. But because this is x squared squared and this is x squared, that's essentially the same as saying u squared plus 3u minus 3 because u is equal to x squared. See, what you're doing is you're rewriting this equation. You're substituting something in, a letter in for x squared, and then you're rewriting it and you can see, oh, this is just a quadratic equation. So I can use the quadratic formula to solve this. So let's do that real quick. U equals -b plus or minus the square root of b squared, which is 9, minus 4a, which is 1, c, which is -3, all over 2a. So that equals -3 plus or minus the square root of 21, all over 2. So there's my answer. But remember, that's for u. That is what u equals, but u is really x squared. So now I'm going to write x squared instead of u. And how do I solve that equation now?
You square root each side.
I take the square root of both sides. So now my answer really is plus or minus the square root of -3 plus or minus square root of 21 all over 2. That's my actual answer. I know that's ugly looking, but that's how many answers is that? Because there's a plus or minus out here and in here,
4.
that means there's 4 answers. Does that make sense?
I'm not gonna lie, I'm so confused.
Yeah. Well, again,
the u thing's really throwing me off.
Yeah, I understand. If your teacher taught you to just do this, what I showed you over here, totally fine. If you understood how to do that, don't mess with the u thing.
But I can't use the quadratic formula with that equation.
You can use it.
But I'd have to like change the equation.
You don't even really have to do the u thing. You could have just gone straight to x squared right here. But just make sure, what I'm saying is make sure that this is to the 4th and this is squared. You understand what I'm saying?
Yeah.
If it's not, then you can't use it. For instance, if the equation said this, 0 equals x to the 4th plus 3x minus 4, you could not use the quadratic formula for that, because that is not a quadratic equation.
Yeah.
Do you understand why?
Because it has it's x to the 4th.
Well, because this is x to the 4th and this isn't x squared. If that was x squared, you could use the quadratic, you could factor and use the quadratic formula, but there's no factoring here. You can't factor this right here. You can't go x squared and x squared, because that would give you, look at what that would give you. If you tried to do that, what would that be? +4 and -1. If you tried to do that, what would happen? Look, you would get 4x squared minus 1x squared, which equals 3x squared. But I don't have x squared here.
Yeah.
I have 3x there. So that wouldn't work, is what I'm saying.
Okay.
You understand?
Yeah.
Furthermore, if you had an equation, and so I guess what I'm getting at is it doesn't really matter as long as you recognize what I'm saying. When you utilize u, when you say, oh, look, I'm going to call this thing here u, and then this thing is just u squared, because x squared, right? I can't do it with that one, but for this one, I'm going to call this u, and then u squared is really the same as x squared squared, which is x to the 4th.
Yeah.
So you're literally just rewriting the equation, and now you can see, oh yeah, look, that's a quadratic equation. You understand what I'm saying? So if you understand what I'm saying, as long as you recognize that you can only use that trick when one of them's x to the 4th and the other one's x squared. Or you could use it like this, watch. If it was x to the 6th and 3x cubed, now you can use it. How would you solve that equation?
X to the 3rd and x to the 3rd.
Very good. Yeah, that's fine. As long as you can recognize that. And see, in my head, what you're saying, in my head, what I'm thinking is this is my u. And then this is u squared. That's all I'm thinking of in my head.
Yeah.
Do you get what I'm saying?
Yeah.
But do you have to literally write u in there? Of course not. Just recognize that you can't do that. You can't use that method for a problem like this, because that is not half of that.
Yeah.
Okay. So this equation would be solved like this. It would be minus 1 and plus 4.
Yeah.
And then you would set each one of these equal to 0. X cubed minus 1 equals 0, or x cubed plus 4 equals 0, which means x cubed equals 1, which means x equals the cube root of 1, which is 1. And this one, x cubed equals -4, which means you have x equals the cube root of -4, which isn't a rational number. So I can't write anything else about for that. So those would be your two answers. You'd have two answers for that one, not 6. Okay.
Yep.
All right. Let's try to run through the rest of these. We only have 5 minutes. Identify the types of roots we have. Okay, so here we go. Well, it's a cubic function, and you can see there's only what?
It only hits it once.
So that means there's one real.
Yeah.
And then that means there's how many other roots? If it's a cubic.
There's two or fake or like invisible.
Imaginary.
Yeah.
So 2 real and 1 imaginary, right? Graph in factored form. Identify and plot all correct x-intercepts and end behavior. So this is a perfect example of what I was talking about. See how this is a 4th degree? Can you see how it's a 4th degree? Can you see that? Because this is the first, this is 1, and this is 1, and there's 2 here. So that's a 4th degree. And you see how the leading coefficient, what's the leading coefficient?
The leading coefficient is,
if you basically
4.
you're multiplying all of these things out. There's actually 2 of them there, right? Because of the squared. So that's like x plus 4 and x plus 4. So if I multiply all those out, my leading coefficient would be just 1, right? Because it's 1x to the 4th. You understand that? Like if I was going to multiply all these out, you don't have to actually do it. But what would the first term be when I multiplied these all out? What would it be? Do you know that it would be this times this times this times this?
Yeah.
It would be x to the 4th plus, and then a bunch of other stuff, which it would be harder to find the other stuff. The first term is easy to find. It's x to the 4th. And what's the leading coefficient?
4.
It's 1. It's 1.
Leading coefficient is 1. The degree is 4.
The degree is 4. That's right. And the leading coefficient is 1. So what do we say about leading coefficient being positive? Which way does it go?
To the right, positive or up.
Yep. And then since it's even, where does it go?
It goes to the left up too.
Good. And then here's the other trick to know. If a 0, this is called multiplicity. Have you learned about this?
Yeah, I've heard of it.
Yep. So multiplicity for a 0, if a 0 has an even multiplicity, then it bounces. It doesn't go through the x-axis, bounces off x-axis. And if it's got an odd multiplicity, it goes through the x-axis. So let's look at our zeros. We have a 0 at, can you see what the zeros are? We have a 0 at, what would it be here for the first term?
3.
3. And does it go through or bounce off? What's the multiplicity?
It goes through.
Yeah, since it's got a 1, that means the multiplicity is 1. M equals 1, all right, for multiplicity. So that means it goes through at x equals 3. Got it?
Yeah.
So it's going to go through at x equals 3. And by the way, that was our rightmost one. So we can just do this because we know it's going to go up there. Okay. Now let's heading to the left. What's our next one going to be? Can you see that it's going to be x plus 4
Yeah.
squared? And that means since the multiplicity is 2, what's going to happen?
It's going to bounce off the x-axis.
Yep, very good. It doesn't go through. My bad. I was going to say go through. It bounces at x equals -4, right?
Yeah.
So it's going down, and then instead of going through, it does what? It bounces. Do you understand what I'm doing here?
Yeah.
See, I'm just creating the graph. I'm drawing the graph like this. And I don't have to be perfect in what I do. I just have to have the end behavior correct and the zeros correct. And then what's my last zero?
X equals -6.
Yep. So at x plus 6 was my factor, and the multiplicity was 1, which meant what?
It goes through
At where?
at -6.
And sure enough, oh yeah, look, it better go through, right?
Yeah.
Where does it have to end up going?
Positive.
It has to end up going up. So there's my graph. Okay, makes sense?
Yeah.
Was that it?
Yeah, that was it.
Oh, we made it. Perfect number of questions. Good job. All right, so hopefully that helps. So you're going to be able to see this on YouTube, on my YouTube channel. So you can go there and check it out.